This flowchart design is for complete 100 TPH silica sand processing plant in Indonesia. The main equipment includes feeder, trommel screen, ball mill, attrition scrubber, desliming cone, spiral chute separator, weak intensity magnetic separator, high gradient magnetic separator, dewatering screen, etc. This flowchart design was based the following raw silica sand conditions and customers' requirements. 1. Type of material, silica sand. 2. Max feed size of raw sand, 2 mm. 3. Size distribution in raw sand, 0.6 mi accounts for 70%, above 0.6 mi accounts for 30%. 4. Customer requests all above 0.6 mi and need to use a ball mill for grinding to minus 0.6 meters. 5. Customer requests the grade of finished product silica sand should reach 99.5% up. 6. Customer requests the content of Fe2O3 in finished product silica sand must be less than 120 ppm, 0.002%. Our plant is hard to achieve this target. We already explained this to customer before designing this flowchart. Our plant can help to reduce Fe2O3 to around 200 ppm. 7. Finished product silica sand size is 0.6 mm. 8. The required plant capacity is 100 TPH. 9. The clay content in raw sand is about 25%. I need to reduce clay to below 3%. The detailed explanation for this flowchart as below. 1. Raw sand is unloaded to the hopper, then through a belt feeder evenly fed to the distribution tank in front of 2 trommel screens. The distribution tank distributes sand to each trommel screen. 2. The trommel screen is set with a 0.6 mm stainless steel screen and 5 mm protective screen. Trommel screen is a wet screening process. It can simply wash the raw material and sieve out. 0.6 mm and plus 0.6 mm which goes to the ball mill for grinding. 3. Ball mill comes with ceramic lining, also named high aluminum lining, because the raw material is silica sand. In order to prevent iron pollution from silica sand, you need to use a ceramic liner ball mill. Ball mill is a wet grinding process. Its output is pumped to a distribution tank in front of 2 trommel screens. 4. Less than 0.6 mm from the trommel screen, go to an attrition scrubber for further scrub off the clay from silica sand. 5. The output of the attrition scrubber is pumped to a desliming cone for removing mud clay and adjusting slurry density that is required by spiral chute separator. The overflow of the desliming cone is mud clay. The underflow goes to spiral chute. 6. The underflow of desliming cone go to number 1 distribution tank above first stage spiral chute separators. Spiral separator is a gravity separator. It can remove some heavy minerals impurities by gravity separation principle. First stage spiral separators have 32 sets. Number 1 distribution tank will distribute slurry to each set spiral. It will generate concentration, middling, tailing. Concentrate is silica sand. Tailing go to the sedimentation tank. Middling are pumped to second stage spirals for gravity separation again. The second stage spiral separators have 14 sets. The middling from first stage spirals are pumped to number 2 distribution tanks, which will distribute slurry to each set spiral. 7. The concentrate from 2 stages of spiral separators are pumped to a weak intensity magnetic separator for removing mechanical iron and magnetite-type iron. 8. The concentrates from weak magnetic separators are pumped to high gradient magnetic separators for removing Fe2O3. 9. The concentrates from high gradient magnetic separators are pumped to a desliming cone for further removing mud clay and thickening slurry. 10. The underflow of desliming cones goes to the dewatering screen for dewatering finished silica sand. The mesh size of the dewatering screen is 120 mesh, polyurethane screen. 11. The dewatered silica sand is transported to the stockpile by belt conveyor. This flowchart has the following advantages. 1. The process flowchart is integrated with sand washing, desliming, gravity separation, magnetic separation, and dehydration, which can fully meet the needs of customers. 2. Compared with a complicated process, this flowchart solution has the features of simple operation, low investment, less maintenance, and fast payback.